It's recording. It's going to work. Don't worry. Everyone's going to be fine. And the microphone's on my iPad, so if I walk over next to you, don't talk. Unless you want to be recorded. Okay, so this is the new thing. This is the thing that we need to remember. Integrals help us calculate accumulation. We talked about that. Integrals help you calculate accumulation, which means if you want to figure out your location in space, you need to know where you started and then add your accumulation. Okay, so we are talking about objects that are traveling along a number line. So here's my number line, and I'm going to put an object. Here's my object. And as my object is traveling along the number line, it's going left and right, right? So the object has a velocity. The velocity is how fast it's moving. When the velocity is positive, it's moving forward. When the velocity is negative, it's moving backwards. The displacement is how far did I move from where I started to where I landed. My total distance talks about how far I traveled when I was on this path, the total distance. And those are all things we've talked about before, but now we're going to add in that we are doing integrals with all of this. So find the object's displacement from 0 to 9. That's how far did I travel from where I started to where I landed, which means the area under the curve for part A gets to be positive, and the area under the curve for part B gets to be negative. Also, just to help myself with all my units and understanding what's going on, the velocity is in feet per second. Those are my y values. And time is in seconds. Those are my x values. So I am finding the integral from 0 to 9 of v of t dt, which is going to be equal to the sum of the two values, a and b, remembering that because b is below the x-axis, that part's negative. So for a, that is a trapezoid. 1/2 times a height of 2 times the sum of the bases, they are 6 and 3. And then b is negative, and it's a triangle, 1/2 base, so 1/2 3 times the height. The height is -4. Oh, no, sorry, the height is 4. So we have 9 minus 6. Our displacement is not just 3, it is 3 feet. Which means from where I started, even though I went really far to the right and then I came back, to where I ended was a 3-foot difference. And specifically 3 feet to the right. If it was -3, it would have been 3 feet to the left.
It's a vector.
Ew. Don't worry, we'll do more of those later too.
Vector.
Okay, find the total distance. Total distance traveled is saying how far did I travel regardless of direction, which is going to be the absolute value of A plus the absolute value of B, which is going to be 9 plus 6, or 15 feet.
Oh, we did this first.
We've done this. Oh, wait, I remember this. Okay, so now this is interesting. I didn't put any tick marks. I didn't label anything on this drawing. So if the starting position was 10, that was at time 0, the starting position was 10, then what is the position at time equals 9? 10 plus 3, or 13. Now, so this is our logic, 13 feet. This is our logical understanding how the world works. Let me show you some math that might help for when it's not logical. So the starting value plus the amount of change equals your final position. Are you guys okay with that? The accumulation of change is the same as our displacement, which is the same as our integral. So 10 plus the integral from 0 to 9 of v of t dt is how we found our final position. And I already knew from up above that was 10 plus 3, and that's why I got 13. It helps to see all that other stuff because it might not always be so straightforward, and being able to understand what's getting plugged in where, that helps. It helps. So for that, let's talk about letter D. It says, what 3 different integral expressions involving v of t that could describe the total distance traveled from 0 to 9? Essentially, you figured out the answer is 15 in part B, but we didn't write it using integral notation, so let's make sure we can understand how to write it as an integral because it's not always going to be a geometry problem. So here's the first one. We could write it as the integral from 0 to 9 of the absolute value of v of t dt. That means that you have to turn it into a piecewise function. With a piecewise function, you are looking at the 2 different pieces and you make sure that you're taking the absolute value of each. That's like saying the integral from 0 to 6 of v of t dt, which was the part that gave us a above the curve, and the integral from 6 to 9, I'm going to have to take the opposite. So minus the integral from 6 to 9 of v of t dt, which gives us the opposite, so double negative, and we end up adding. Alternately, and this one's kind of fancy, the negative part, instead of subtracting it, you could reverse the order of the indices. So you would go the integral from 0 to 6 of v of t dt plus the integral from 9 to 6 of v of t dt. All 3 of these are equal. They all give you the same answer, just different ways of doing the same thing. Fancy. Okay, now please promise me you will not lose your minds on this next one.
No.
The next 2, everybody stay calm. Don't make this more complicated. E is average rate of change, and F is average velocity. Pop quiz. Do you remember how to do those? Ugh. Oy. Ugh. V of 2 equals 2. V of 6 equals 0. Average rate of change is slope. So 0 minus 2 over 6 minus 2 is negative 2/4 or negative 1/2. Now let's put our units in. It was y over x. My y values were feet per second. My x values were seconds. So I have negative 1/2 feet per second squared. You could also leave feet per second. It's correct. They won't mark you wrong. So then average velocity is going to be the area of the integral, right? The area under the curve over the amount of time that was spent. So the formula for that one looked like this. So the average value is going to be 1 over b minus a. So that's the amount of time. Oh, thank you. Hi. Thank you. It's for you. Times the integral from a to b of v of t dt. So in this case, we're going from 2 to 6. So we have 1/4, and then from 2 to 6, we're looking at this area. From 2 to 6 is this trapezoid right here. So that's going to be 1/2 times the height of 2 times the sum of the bases. The bases are 4 plus 3. So that's going to be 7/4. And this, what are your units? Feet per second. We're feeling okay? Like, oh wait, this is review. I remember. It's easy. No, not that good. Okay.
It feels like very bad.
Okay. Next page is a different problem, but it's the same stuff. So I'm going to set a timer and have you try this without me. This is your axis. It's a little hard to see in this graph. So you can see that this blue section is above the x-axis. And this green is below the x-axis. Or if you're colorblind like my kid, he'll tell you that's yellow. It's a very yellow
Wait,
green.
if you're colorblind, can you drive?
Yes. Because stoplights are always in the same order, so it doesn't matter what color.
I would like totally start Elmer.
And people who are colorblind, they don't see in black and white the way a black and white photo is. They just see in subdued color tones. So everything looks like brown and red to them.
Do you know the theory that like we all see different colors?
It could be, no one would know.
That would be, I believe
I
that.
said
My
that to my
wife's so
parents
smart.
and they did not believe me. They hated that. They
I'm setting the timer. You have 4 minutes. Go.
No.
I did.
It also happens when like some languages have more words.
Sorry.
It also happens in other languages where there are less words describing them, so like light red and stuff. If it's
She really does.
I'll just like watch it.
That's what I did.
Just like parameters. Where's actually the pencil sound?
630. 60 times 1/2 is 30. 30 is 1050. 1050.
You are correct. 1050. Accurate.
1050.
This is a secret. This is more than the last block. Yeah, I'm waiting for it to like.
30 to 55 is 25.
I would have to say. I would probably skip.
You split it into two triangles. The same. 25 by 1/2.
What are you saying? What are you
Or negative 40.
I could take it with me, but you'd have to skip 10. And you'd have to
like an
say,
hour away?
Negative 20.
We're not having
It's
you
fine.
have
I
to
would
pay
just walk.
security guards and you have to find.
Negative 5. 1050 minus 500 is 550. That's the displacement. Total 450. Huh?
I'll say 450.
Yeah, that's the displacement. And the total distance is 50.
The first one?
Yeah.
Like do A?
Meters.
505?
This is meters. An object with a position 10 meters. 0.
Oh, yeah.
What is the
Oh, yeah,
position 5?
Yeah, I got the,
Okay, a
my
base
decimal.
Plus 150.
20 by 60 by 25, 30, divided by 30, and 60.
I have very, now I'm 1550.
Subtract it and minus.
I'm not done with the first one.
Me neither. You can have until I'm done writing.
Write the integral expression for b of t squared.
Whew. Okay, here we go. I know, adding is hard.
Wait, but 50 plus 10. Positioning.
How are we feeling?
I don't get C.
We need to talk about C.
Yeah.
So the object was at position 10 meters, meaning it didn't start at 0, 0. I know that this graph of velocity starts at 0, 0, but the actual position of the object didn't start at 0, 0, which means that your displacement from part A moved you from where you started.
Oh.
So you started at 10, you add your 550, that's what displacement means. Okay? Here's the next part. So, waiting. So we've got our three different integrals. They're the same as from up above, it's just using different numbers. Then we found our average rate of change using our slope idea. It's negative 4/3 meters per minute squared. First semester, we struggled with units. When I asked you to explain to me what that means that the rate of change is changing. Negative 4/3 meters per minute for every minute. We had a hard time writing that in a sentence, so it's a good thing to practice thinking about that while we're looking at these. And then our average velocity, I chucked it in a calculator at the end there. This is in meters per minute. Waiting for questions. Okay.
Wait, why is it 30 to 55 for BFTB? For the third integral?
Because I have to split it at the place where it goes from being positive to negative. So it goes from 0 to 30 as positive, and then from 30 to 50 underneath the x-axis, negative values.
Yeah, but why was it switched on the integral we're talking about?
Because when you switch the order, it changes the sign to be the opposite. So I could either put a negative in front or I could switch the order. Okay, this is our last one for today. Here we go. Pollution's being removed from a lake at a rate modeled by this exponential function, y equals 20 e to the negative 0.5 t, tons per year. This is roughly an exponential decay function. These are my y's, these are my t's. This is in tons per year. This is in years. This first year, year 0, is 1995, and they want us to go up to 2005, which is 10 years later. The amount of pollution removed in tons is going to be the accumulation under this curve, which means we're finding the integral from 0 to 10 of the equation 20 e to the negative 0.5 t dt. We are going to do this in Desmos. Desmos is going to be available to you on the calculator parts of the test, and so I want to start practicing with it a little bit. Make sure we know what we're doing. So in Desmos, you can type in your equation. I typed it into y1. You could also type in your equation directly using in the functions menu. There is a calculus function section right here. There's my integral. You can type it in and reference y1, or you could have typed it in as 20 e to the negative 0.5x. The dx doesn't have a special button. I found the dx. Let me make this bigger. I found the dx by using my ABC menu and just typing dx, and it was able to put it in for me. Okay? The instructions say round to the nearest ton, which means that 39.73 is approximately 40 tons.
Wow.
Worth practicing with and making sure you can feel comfortable with that, okay? We got like 2 seconds left.